Hello friends, this video on Semiconductors Part 13 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till Part 12 before going ahead with Part 13. So now that we have seen what is a semiconductor diode, what is it made up of, how does it work, it is time that we discuss about some of the important applications of semiconductor diode. This diode has got huge number of applications. The first one being a rectifier. A diode can be used as a rectifier. Zener diode is again a semiconductor diode. There are many optoelectric junction devices which makes use of light and electrical energy. There are many such devices like photodiode, light emitting diode, solar cell. They are all nothing but applications of diode. So we will discuss each one of them in detail one by one. So let us start with diode as a rectifier. How does a diode act as a rectifier? So before knowing that, we should know what is a rectifier. What does a rectifier do? A rectifier is basically a device which converts a bidirectional signal into a unidirectional signal. For example, if you apply an AC input voltage to a rectifier, the output which you will get will be, because AC input is like bidirectional, it has positive half cycles as well as negative half cycles, right? But the output which you will get from this rectifier will be in one direction. So that is a rectifier. So how does a diode act as a rectifier? So let us look at it. Now there are two categories of rectifier. One is known as a half wave rectifier and the other one is known as a full wave rectifier. Let us discuss half wave rectifier first. So what happens in case of this half wave rectifier? Let us suppose we have an input signal somewhat like this. This is how your input AC signal will look like. It will change with time sinusoidally, right? So what kind of output do you expect to get when it passes through this half wave rectifier? So we will see that. So what happens when during the positive cycle, that means during the cycle when this positive half is input, acts as the input. So during the positive cycle, the voltage at this point A is positive, right? See, because the input voltage will either be either the positive cycle or the negative cycle. So during the positive cycle of the input voltage, that means when the input voltage is positive, the point A, voltage at point A is positive. Now when the voltage at point A is positive, this is my diode, this is positive of the diode. So the positive of the diode is connected to the positive terminal. So that means the diode is forward biased. Now if the diode is forward biased, it conducts current. Right? So the diode will conduct current. So this is my positive cycle. So in the positive cycle, this was the input. So this will be the output. Now what happens in the negative cycle? Negative cycle means when negative voltage is applied, when this part of the voltage is applied as input. In that case, what happens? The voltage at A is negative. So at this point, the voltage becomes negative. Therefore, the positive of the diode is connected to the negative. As a result, the diode is reverse biased. Therefore, it conducts zero current. Why zero current? You might say that even during reverse bias, there was drift current which flew, right? But the drift current is very small. That's what we saw even from the VI characteristics of the diode, that the reverse saturation current is very, very small, right? Until and unless we reach the breakdown voltage. So right now we are not talking about the breakdown voltage. Okay. So when the negative cycle is applied, the voltage at A is negative. So the diode is reverse biased. Therefore, it will not conduct any current. So that means the current conductance will be zero for the negative cycle. Again, the positive cycle will come and the diode will again conduct. So it would be somewhat like this. Again negative cycle, nothing. Again positive cycle, it will conduct. Again negative cycle, nothing. So this is how your output will look like. So from the output, what you can see? You can see that in this case, it is unidirectional, right? So that is the purpose of a rectifier. So the rectifier always gives, so this unidirectional output is known as a rectified output, right? Then that is the purpose of the rectifier. So if you compare the input signal and the output signal, what do you see? The frequency of the input signal and the output signal is the same. See, this is one cycle. For this is one cycle. Again, this is another cycle, and this is another cycle. So the frequency of the input and output is same. Frequency of input is equal to frequency of output. What is frequency? I hope you all remember all these things. Frequency is the number of waves which are covered in one particular wavelength or in a certain period of time. So if you compare from this point to this point, so that is equivalent to this point to this point. So how many waves? Here also it is 1, here also it is 1, right? So the frequency of input is equal to the frequency of output. Now let us talk about the full wave rectifier. In full wave rectifier, what happens? Instead of one diode, we now have two diodes, D1 and D2. Otherwise, the arrangement remains the same. But in this case, we have a center tap in the middle of this transformer. So this transformer, I mean, if you look at, right now I am not discussing much about the construction of the rectifier because right now our concentration is on the diodes. So basically it has got a transformer so that the input voltage which you apply here, that input voltage, all these things I have studied in, I taught you in your earlier lessons, right? So this is your primary coil, this is your secondary coil. So the input voltage is applied across the primary coil, so it will get inducted to the secondary coil. Now in a full wave rectifier, the center tap is there. That means the voltage at A or B is measured with respect to the center tap, right? So in this case, what happens? Let us suppose this is my waveform at A and this is my waveform at B. So how do we get this waveform at A and B? Let us suppose I have got an input signal, again a similar input signal. This is my input. So in this case, what will happen? During the positive half cycle, let us again talk about the positive half cycle. So during positive cycle of the input, what happens? The voltage at A will be positive, whereas with respect to the center tap, and the voltage at B will be negative, right? Because both cannot be positive. One has to be positive and the other has to be negative. So when I am talking about the positive cycle, voltage at A is positive and voltage at B is negative. As a result of this, D1 is forward biased and D2 is reverse biased. So that means D1 will conduct and D2 will not conduct. So what will be the output? This will be the output which will be due to D1, right? Okay. Now what happens during the negative cycle? Now when the negative cycle comes into picture, so during negative cycle of the input, A is at negative, right? So right now we are talking about the negative cycle. So if you see, A is at negative, so the waveform at A is negative. B is at positive, so the waveform at B is positive. So when A is negative, this positive is connected to the negative. So that means D1 becomes reverse biased and D2 in this case, since this is positive and this is also positive, so D2 becomes forward biased. So here D2 will conduct and D1 will not conduct. So therefore again we will get one waveform, but this is due to D2. So this process will keep continuing, and what do we get? We get a more efficient output, because in the half wave rectifier we were getting unidirectional output but not in every cycle, but now we are getting a unidirectional output in each and every cycle. So the efficiency of the full wave rectifier is better than that of the half wave rectifier. And also if we compare the frequency of the output with the input, in this case what do we see? if you compare just one cycle of the input, how many waves are there? Just one wave. And if you compare the respective cycle of the output, how many waves are there? There are two waves, right? So here, in case of a full wave rectifier, frequency of output is equal to 2 times the frequency of input. Right? So this is how we see that the semiconductor diodes can act as rectifier. So let us now look at the next application, that is the Zener diode. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.